Hi gentlemen, these will be your notes for Unit 3, Day 3 of Algebra 1. If you would like to see the warm-up, review question, or any homework questions we covered in today's class, just look at the finished notes. So today we're going to talk a little bit more about linear functions and equations. We're going to be able to talk about their intercepts, so where it crosses the x and y axis, and to use those points to be able to graph lines. We'll talk about horizontal and vertical lines and what their slopes are. We'll talk about how to find the slope of a line if we see its graph, and how to find the slope of a line if we have 2 points that would make its graph. So identifying intercepts. So there's 2 different types of intercepts. You have x-intercepts and you have y-intercepts. And an intercept is where the line or your function or the picture of the graph crosses each axis. So right here, we would call that the y-intercept, and right there, we would call that the x-intercept. So the points where it hits the x-axis are called the x-intercepts, and the points where it hits the y-axis are called the y-intercepts. So on our first picture right here, that point right there is called the x-intercept because that's the point where the blue line crosses the x-axis, and that is the point x is -5 and y is 0. The y-intercept is this point right here, and that's the point where it crosses the y-axis. So this is called the y-intercept, and that's the point where x is 0 and y looks to be about 1.75. So notice the x-intercepts are always going to be where the y-coordinate is 0, and the y-intercepts are always going to be where the x-coordinate is 0. So let's look at that next picture. So we have x-intercepts at 3 different places. So we have an x-intercept at the point -3, 0, at the point 0, 0, and at the point 3, 0. So those would be your x-intercepts. And the y-intercept, well, it looks like it crosses the the y-axis at the same place right there where it crosses the x-axis. So the point 0, 0 is also a y-intercept. On our next picture, there are no y-intercepts because it doesn't cross the y-axis anywhere, but you have an x-intercept at the point 2, 0. On our next picture, we don't have an x-intercept, but we do have a y-intercept, so it crosses the y-axis at the point 0, 2. On our next picture, it's a circle, so it has 2 y-intercepts and 2 x-intercepts. So it has y-intercepts at the points 0, 2 and 0, -2, and it has x-intercepts at the points 2, 0. Oops. Nope, these are not 2s, they're 3s. Sorry about that. So 0, 3 and 0, -3, and it has x-intercepts at 3, 0 and -3, 0. So again, those right here and right here are your x-intercepts. And then your y-intercepts are here and here. So x-intercepts are where the graph crosses the x-axis, and y-intercepts are where the graph crosses the y-axis. How do we find intercepts by hand? So without the graph. Well, to find x-intercepts, again, they're the point where the graph crosses the x-axis. So it's any point on that line right there. Well, what's true about every y value on that line? Well, here y is 1, here y is -1. So on every point on that pink line, the y is 0. So to find x-intercepts, you let the y equal 0 and then solve for x. So for instance, if I have 2x plus 5y equals -18, and I want to know what the x-intercept would be on that graph, we're going to plug in 0 for the y-coordinate. So it'll be 2x times 5 plus 0 equals -18. So this would be 2x. 5 times 0 is 0 equals -18. So 2x equals -18. And then to solve for x, divide both sides by 2. And so my x-intercept would be -9. Or it's the point when x is -9 and y is 0. So to find x-intercepts by hand without knowing what the graph looks like, you just let y equal 0 and solve for x. If you want to find a y-intercept by hand, So a y-intercept is where your graph is going to cross the y-axis, and then notice everywhere on that line, that's where the x-coordinates are equal to 0. So if you want to find a y-intercept, you let the x-coordinate be 0, and then you solve for the y. So if we use the same one, 2x plus 5y, well, let's make it nice, equals negative 15. If we wanted to find the y-intercept, we're going to plug in 0 for x, so it'll be 2 times 0 plus 5y equals negative 15. 2 times 0 is 0, so 0 plus 5y equals negative 15. 0 plus 5y is just 5y. Divide both sides by 5. And my y-intercept is going to be at negative 3, or it's at the point when x is 0 and y is negative 3. So that's how you find an x-intercept and a y-intercept by hand. To find x-intercepts by hand, you let the y-coordinate be 0, plug in 0 for y, and then solve for x. To find a y-intercept by hand, you let the x-coordinate be 0, so plug in 0 for x, and then solve for the y. So if we want to graph linear equations, so we already graphed them by using tables. If we want to graph linear equations by finding their intercepts, well, you can make a table if you want to. And we know we have to find when x is 0 and when y is 0. So to find an x-intercept, you let y be 0. So if I plug in 0 for the y, I get 3x minus 4 times 0 equals negative 12. And so this would be 3x minus 0 equals negative 12. Divide by 3, and x is going to be negative 4. So I know that I have a x-intercept of negative 4. If I want to find a y-intercept, we let x be 0. And so if I plug in 0 for my x, I get 3 times 0 minus 4y equals 12. 3 times 0 is 0. So negative 4y equals 12. Then divide by negative 4, and y is going to be negative 3. Oops, sorry, that's negative 12. So negative 12, and then this would be positive 3. So that means that 2 points that would be on this line would be the point 0, 3. So there's my y-intercept. And then negative 4, 0, 1, 2, 3, 4. So that's the point negative 4, 0. So that's my x-intercept. You need 2 points to make a line. So if I connect those 2 points, that would be my line for 3x minus 4y equals negative 12. So those are 2 specific points that you can find if you want to graph a line. On the next one, 5x equals 2y minus 4. Again, we can make a table. We need to know what happens when x is 0 and what happens when y is 0. So if we want to find an x-intercept, you let y be 0 and solve for x. So this would be 5x equals 2 times 0 minus 4. 2 times 0 is 0. So 5x is going to equal negative 4. Divide both sides by 5. And y is going to equal negative 4/5, which is negative 0.8 if you divide that out. So my x-intercept is negative 0.80. And then if I want to find my y-intercept, I'm going to let x be 0. So this would be 5 times 0 equals 2y minus 4. So 0 equals 2y minus 4. Add the 4 over. So 4 equals 2y. Divide both sides by 2. And the y-intercept is 2. So that would be the point 0, 2. So if I go to graph this, I would have a point at 0, 2. So that's my y-intercept. And then at negative 0.80, that would be my second point. That's my x-intercept. If I connect those two, that would be the line that would work for 5x equals 2y minus 4. And that's how you can graph using intercepts. Vertical lines. You guys might know the definition of vertical. So vertical means up and down. So vertical lines are lines that go straight up and down. How do we make a line go straight up and down? Let's think about this. What points would exist on a line that goes straight up and down? So let's just graph a vertical line. We could put it anywhere we want to. So let's put it right here. What points exist on that line? Well, it has an x-intercept, right? And that's the point 3, 0. So I know the point 3, 0 exists on the line. What about this point right here? Well, that would exist on the line, and that is the point 3, negative 1. we know this point right here exists on the line, and that could be the point 3, positive 1. We could do this point right here, and that would be the point 3, negative 3. What are you noticing about all of the points on that line? What do they all have in common? The x value is always 3. So if you want to graph a vertical line, it's when the x coordinate is constant. So the equation of the line looks like x. So it's x equals some sort of number. So x is equal to a number makes a vertical line. So you make a vertical line at whatever the x coordinate is. So if I had x is equal to 4, if I made a table of values, it's when the x coordinate is always 4. And then the y coordinate could be anything like 0, 1, and 2. So if the x coordinate is always 4, 1, 2, 3, 4, I could have that point, and that point on the line. If I connected them, notice you have a vertical line where x is always equal to 4. Or we could have the line x is equal to negative 2. That is the line where the x coordinate is always negative 2. So we could do 0, 1, 2, or 1, 0, 2 for the y's. So we would have negative 2, 0, 1, and 2. And so again, that's a vertical line, but this time it's where the x values are always equal to negative 2. What if we had x equals 5? What would that graph look like? So you guys go ahead and take a minute and graph x is equal to 5. So that's the vertical line where the x coordinates are always equal to 5. Horizontal lines, you also may know what these look like. These are the lines that run left to right. They're perfectly horizontal. So if I were to do an example of a horizontal line, we could graph one right here. And let's just put some points on that line. Well, I know that's a point on the line, and that is the y-intercept, and it happens at 0, 2. I could put this point on the line, and that is the point where x is 3 and y is 2. I could put this point on the line, and that's the point where x is negative 4 and y is 2. What are you noticing about all of the, all of these have in common? We have negative 4, 2, 0, 2, and 3, 2. All of those points have the same y coordinate. The y coordinate is always 2. So horizontal lines are going to be y equals lines. So horizontal lines are going to be when y is equal to a given number. So for instance, if I had y equals negative 5, that would be the line where the y coordinate is always negative 5, where it's a horizontal line that's 5 down on the y-axis. Or we could have y equals positive 3. That would be a horizontal line that's 3 up the y-axis, and it's all of the points that are where y is equal to 3. So you guys go ahead and graph the line y is equal to 0. So that would be a horizontal line where the y values are always equal to 0. So it would be the same thing as the x-axis. All right, let's graph each of these lines. So we have 4 equals x minus 6y. So we can graph these using points. Since we used intercepts before, let's use intercepts now. So if I want to find the x-intercept, I'm going to let y be 0. So if I let y be 0, I have 4 equals x minus 6 times 0. So I just have 4 is equal to x. So my x-intercept is going to be the point 4, 0. If I want to find the y-intercept, I let x be 0. So 4 is going to equal 0 minus 6y. So 4 equals negative 6y. Divide both sides by negative 6, and I get negative 2/3 is y. So negative 0.667 as a decimal. So my x-coordinate, or my x-intercept, it's going to cross the x-axis at 4, 0, and it's going to cross the y-axis at negative 6.670. So that would be one way to graph this line. On the next one, I have y minus 5 equals 0. Well, that's pretty close to being a horizontal line. What if I added 5 to both sides? I would have the line y equals 5, and that is a horizontal line because it's y equals, and it's the line where the y values are always equal to 5. So it's 5 up on the y-axis. Same thing on the next one. It looks pretty close to a vertical line. Let's subtract 4 from both sides, and I get x equals negative 4. So that is the vertical line where the x-coordinate is always equal to negative 4. So 1, 2, 3, 4. So it is 1, 2, 3, 4. So it's the vertical line where the x coordinate is always equal to -4. All right. The slope of a line. So a lot of you guys probably remember about learning about slope last year or the year before. Slope, you guys might remember, it's the rise over the run. So how many did you rise up or how many did you fall down? And then how many did you run or run? If you fall or move to the left, you're moving in the negative direction. If you're rising or moving to the right, you're moving in the positive direction. The letter that we use for slope is M. So M is going to be the rise over the run. Or you might remember the slope formula. It's the change in the y values over the change in the x values. That triangle is the Greek letter delta, and it means change in. So how are the y's changing and how are the x's changing? Or the slope formula is y2 minus y1 over x2 minus x1. So there's a whole bunch of different ways we can talk about the slope of the line. But if you're given a graph, we can just think about it as rise over run. So you would just start at one point on the graph and you think, how do I move to the next point on the graph? So to move from the first blue dot to the second blue dot, I rose up 2 and I ran over 1. So my slope is going to be, I rose up, so that's positive, and I ran to the right 1. So my slope is going to be 2 over 1 because that's my rise over my run. So my slope, which is just M, we can use the letter M, is going to be 2 over 1 or 2. On the second one, we have this point right here and this point right here. So what's my slope going to be? Well, to go from the first dot to the second dot, what did I do? Well, I fell. So I fell 1, 2, 3, 4, and I ran over 1, 2, 3, 4, 5. So I fell 4. So I went down 4 and I ran over 5. So since I fell 4, 1, 2, 3, 4, and ran over 5, my slope is going to be -4 because I went down and then to the right 5. So that's my rise over run. Even though I didn't rise, I actually fell. It's going to be -4/5. So my slope is -4 over 5. So you guys take a minute and see if you guys can find the slope for each of these lines. So the slope in between those points. You guys can pause the video and try and find the slope for each 4 of these graphs. So on this first one, I have this point to this point. So to go from the first dot to the second dot, I read it from left to right. I rose up 1, 2, 3. So I rose up 3 and I ran over 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe. So I went from -4 to +5. Yep. So I rose up 3 and I ran over 9 and I moved in the positive direction for each one. So my slope, which is M, is going to be 3 over 9, which you could also reduce to 1 over 3, which means that I also rose up 1 and ran over 3. Rose up 1, ran over 3, rose up 1, ran over 3. So you could also look at it like that. On the next one, I'm moving from this point to this point. So to go from the first point to the second point, I went down 1, 2, 3, 4, and I ran over 1, 2, 3, 4, 5, 6. So I fell down 4 and I ran over 6, I believe. -4 to 2 is 6, and 3 to -1 is 4. Yep. So my slope, I fell down 4 and I ran over 6. So my slope, which is my rise over my run, since I fell, it's going to be negative. So -4 over 6, which I can reduce to -2/3. So I could also go down 2 over 3, down 2 over 3, and that works as well. Let's look at the next one. I have this point and I have this point. So there's my first point, there's my second point. How did I move from one point to the next? Well, I fell down from -12 to -2. So I fell down -14. Be careful. You got to notice what's happening on the y-axis. They weren't going by ones this time. I went down 2, 4, 6, 8, 10, 12, 14. And then I ran over, again, these are going by twos, so 2, 4, 6. So I fell down 14 and I ran 6. So my slope, my rise over my run, so I fell 14, so negative 14 over 6, which reduced to negative 7 over 3. So if I went down 7, so 2, 4, 6, 7, and ran over 3, it works. And then if I fell down 6, or sorry, fell down 7, so 1, 3, 5, 7, and ran over 3, that works as well. On the next one, I have a vertical line. So how did I go from my first point to my second point? Well, I fell down, and this is going by ones, so 3. I fell down 6, but I didn't run. My run is 0. So my slope is my rise over my run. So I fell down 6 and I ran over 0. You can't divide by 0. 0 can't be in the denominator of a fraction. So since you can't divide by 0, this means that the slope is undefined. Oops. The slope is undefined, or you can say that there's no slope. So if there's a vertical line, your slope is going to be undefined, or you can call it no slope. What would it be for a horizontal line? So let's say we had this guy. And we had 2 points. So we have a point here, and we have a point here. Well, for a horizontal line, what's my rise? I didn't rise at all. So my rise is going to be 0. And then my run going from this point to this point would be 3. So my slope is going to be rise over run, which would be 0 over 3. So for a horizontal line, my slope is going to be 0. So for vertical lines, the slope is undefined. And for horizontal lines, the slope will be 0. So that's one way to find slope, is based on the graph. Another way to find slope is with the slope formula that we talked about before. So slope, again, the letter that we use for slope is m, and it's rise over run, or it's the change in the y's over the change in the x's, so delta y over delta x, or you can do y2 minus y1 over x2 minus x1. So the first point you can call x1 and y1. And then the second point, you can call those coordinates x2 and y2. So what we can do is, if we want to find the slope between 2, 4 and 1, 3, we can call this the first point and this the second point. It really doesn't matter who's the first and who's the second. But we're going to call that the first point and that the second point. So if we wanted to find their slopes with the formula, the point 2, 4 would represent x1 and y1, because that's the first point. And then the second point would be negative 3, 1. So this would be x2 and y2. So if we use the slope formula, the change in the y's are how the y's are changing. So you're subtracting the two y coordinates. So this would be 1 minus 4, because you have y2 minus y1. So that would be 1 minus 4. And then you would have over x2 minus x1. That would be negative 3 minus 2, because that would be your x2 and your x1. So you subtract those. And if I do this, I get negative 3 over negative 5. And a negative over a negative is positive. So my slope should be 3/5. So you can also find slope by using the slope formula. Or you could graph these 2 points. So 2, 4 would be 2 over and 4 up. So that's the point 2, 4. And then the other point is negative 3, 1. So that's the point that's negative 3 to the left and 1 up. And then if I connect those, there's the line. And so my slope between those 2 points, well, I rose up 3 and I ran over 5. So my slope visually would be 3 up and 5 over, which is what we got with the formula as well. So let's do one more together. Let's look at that ugly fraction one together, and then I'll have you guys try A. So again, your slope formula is y2 minus y1 over x2 minus x1. So that's your slope formula, the change in the y's over the change in the x's. So we can call that the first point and that the second point. So we have x1 and y1, x2 and y2. So I'm going to do y2 minus y1. So I'm going to do 2 minus negative 1/2 over. Now I'm going to do x2 minus x1. So I'm going to do 1/2 minus negative 4. Well, 2 minus negative a half would be 2 plus a half, so that's 2.5, over 1/2 minus negative 4, that would be 1/2 plus 4, which would be 4.5. Now, we can't have decimals and fractions, so we're going to move the decimal over once and move the decimal over once. And so this is going to be 25 over 45. And if I reduce that, I would get 5 over 9. So my slope should be 5 over 9. Well, let's check that by graphing. So negative 4, 1, 2, 3, 4, and then negative a half, so it'd be right here. And then 1/2 and 2. All right, so what's the slope between these? I went from negative 1/2 up to 2. So I went up 2.5. So I went up 2.5. And I ran over, well, I started at an x value of negative 4. And I went over to an x value of 1/2. So I went over 4.5. So I went up 2.5 and over 4.5. And that's what we got right here. And then when you simplify that, because you can't have decimals and fractions, you get 5/9. All right, you go ahead and pause the video and see if you can find the slope of the first one. All right, so our slope formula is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. And so it's going to be 1 minus negative 5 over 2 minus negative 3, which would be 6 over 5. So if I graph this, my slope should be 6 over 5. So negative 3, negative 5, and 2, 1. So if I find the slope between those 2 points, I should have 6 over 5. Well, I rose up 6, and I ran over 5, so that is correct. We found it correctly. So the slope of horizontal and vertical lines. We talked about this briefly before, so remember slope is going to be rise over run. So how many did it rise and how many did it run? So if I went between these 2 points, how many did I rise? I didn't rise at all, so my slope is 0. And then how many did I run over? So 3, 6, I ran over 6. But 0 divided by 6 is 0. So the slope for a horizontal line, and remember horizontal lines run left and right, the slope is going to be 0. What if we had a vertical line? So remember slope is rise over run. So if I went between these 2 points, I rose up 2. And how many did I run over? Well, I didn't run over any, so it's 2 over 0, and you can't divide by 0, so that's undefined. So you can say undefined, or you can say no slope. So if it's a vertical line, the slope for vertical lines is going to be no slope or undefined. All right, so let's go ahead and find the slope between those 2 sets of points. So go ahead and pause the video and see if you can find the slope between those 2 sets of points. All right, we have x1, y1, and x2, y2. So my slope is going to be 3 minus 5 over negative 2 minus negative 2, which would be negative 2 over 0. So that means that would make a vertical line. So the slope is undefined, or you can say no slope, because you cannot divide by 0. On the next one, we have y2 minus y1, so 2 minus 2 over x2 minus x1, so negative 3 minus 0. So this would be 0 over negative 3, and 0 divided by anything is 0. So that would be a horizontal line if we graphed it, and so the slope would be 0. So parallel lines and perpendicular lines. So this might be something that you guys remember as well. Parallel lines are those lines that look like train tracks. So they're the lines that run side by side, and they never intersect. So parallel lines look like train tracks. They never intersect. Okay, they look like the train tracks and they never intersect. The symbol that we use for parallel lines are like 2 little lines that look like they're parallel. So what's the same for these 2 lines? Let's look at that first line right there. Those are the 2 points that they picked on it. What's the slope of that line? Well, I rose up 2 and I ran over 1. So the slope of the first line is 2 over 1. Let's look at the slope of the second line, the red line. So if I look at the slope of the red line, I went up 2 and over 1. So the slope of my red line is 2 over 1. What do you notice about the two lines? They have the same slope. So parallel lines have the same slope. So two lines are going to be parallel if they have the same slope. Perpendicular lines. So another word that you guys might remember is perpendicular. Two lines are perpendicular if they form a perfect T, or they intersect at 90 degrees. So they intersect at a 90-degree angle. So the angle in between them, and to show that it's 90 degrees, we make a little box in the corner. So two lines are going to be perpendicular if they intersect at a 90-degree angle. And the symbol for perpendicular is an upside down T. So let's go ahead and look at the slopes of these lines. If I wanted to find the slope of the blue line, let's pick 2 points. So I'm going to use this point and this point. So if I found the slope there, I rose up 2 and I ran over 1. So the slope of my blue line is 2 over 1. And then let's look at the slope of the red line. We'll use this point and this point. So I fell down 1 and I ran over 2. So the slope of my red line is -1 over 2. What do you notice about those two slopes? 2 over 1 and -1 over 2. So perpendicular lines, what can you tell about their slopes? Their slopes are opposite. One's positive, one negative. So they have opposite. One's positive, one's negative. And what do you notice about 2 over 1 and 1 over 2? What do we call those? They're reciprocals. So they have opposite and reciprocal slopes. So you're going to know two lines are perpendicular if their slopes are opposites and reciprocals. So opposite means one's positive, one's negative, and then reciprocal is when you flip over the fraction. So parallel lines have the same exact slope. Perpendicular lines have slopes that are opposites and reciprocals. We can also think of slope in the real world, and in the real world we call it a rate of change. So it's the change in the y values over the change in the x values, but the y value and x values are going to have units attached. So like miles per hour or liters per day. They're going to have a real world context. So the x-axis and the y-axis are going to have units attached to them. So for example, in our first example, the x-axis has the unit years attached, and the y-axis has the unit money attached. So if my slope is the change in y over the change in x, then what are going to be the units represented by this? Well, if the y is money, it's going to be the change in the money over the change in the year. So it's going to be money per year. So when you find the slope, it's going to represent the money per year. And in this case, it's going to be the resale value of a refrigerator. So if I found the slope of this line, we could use that point and that point. So to find the slope, I would go down 100 and over 3. So my slope would be -100 over 3, or it's -100 over 3. So it's -$100 over 3 years. So it's going down $100 every 3 years. So the amount that your refrigerator is going to be worth, it goes down $100 in value every 3 years, according to that graph. On our next one, remember slope, which is a rate of change if we're talking about units, is the change in the y over the change in the x. So my units on my y-axis are inches. So it's going to be the change in the inches over the time on my x-axis, or sorry, the units on my x-axis is time, so it's going to be the change in hours. So my slope in units is going to be inches per hour. So how many inches is it changing every hour? So the slope of this, I'm going to use this point, which is 0, 0, and it looks like this is a good point right here, and it's going by ones every time. So it looks like I rose up 2 and ran over 1. So my slope looks to be 2 over 1. Which looks like it's going to rise 2 inches per hour. So the snowfall looks like it's going to rise 2 inches per hour, or every hour it snowed 2 inches. All right, so Karen's marathon, it looks like she has a whole bunch of different rates. So again, your slope is the change in the y over the change in the x, and this time our y value is in miles, so it's going to be the change in the miles, and then our x value is in hours, so it's going to be the change in the mile over change in the hours, or it's going to be, your slope is going to be represented by miles per hour. Okay, so let's look at what her slope is for the first little part of her marathon. So the first part of her marathon, her slope is she rose up 6 and she ran over 1. So it looks like for part A, her slope is she rose up 6 and ran over 1, and that's miles and that's hours. So she's running at 6 miles per hour for part A. Go ahead and see if you can figure out how fast Karen was running for the rest, for part B, part C, part D, part E, and part F. So go ahead and pause the video and find Karen's rate of change on those different parts of her marathon. All right, so for part B, it looks like she rose up 3 and ran over 1. So her slope would be 3 over 1. So for this part B of her marathon, she was running 3 miles per hour. And then for part C on her marathon, it looks like she was holding steady. So her rise, she didn't rise at all, and her run looked to be about 0.5. But since she didn't rise at all, she was going 0 miles per hour, meaning that Karen was stopped during that part of the race. So it looks like she was stopped for about a half hour. On the next part, it looks like we're going to use this point right here. That looks like a better point. It looks like she rose up from 12 to 18. So she rose up 6 and ran over 1. So for part D, her slope looks to be 6 over 1, or she was running 6 miles per hour again, just like she was on the first part of the relay or the marathon. And then part E, it looks like she was stopped again. So for part E, she rose up 0 and ran over 5, or her slope was 0 over 0.5, so her slope is 0. So she was going 0 miles per hour, or she was stopped again for another half hour. And then for the last part of the race, I'm going to use this point. Oh, none of them look to be very pretty. And this point right here. So it looks like she rose up from 21 to about 26. So 21 to 26, it looks like she rose up 5 and ran over 1. So for that last part, I would estimate that she rose up 5 and ran over 1. So it looks like for that last part of the race, she was running 5 miles per hour. And so that's how we can view slope as a rate of change. All right, gentlemen, for your homework, you have 3.3 and 3.4.